This lesson is about humidity, water vapor in the air. First, I'm going to start with some background information. This will help you understand how the water cycle fits into humidity, and then later we'll be discussing clouds. First, with increasing temperatures and water weather patterns, climate change will affect evaporation rates in many areas. Evaporation is a major part of the Earth's water cycle. In the water cycle, water from lakes, ponds, rivers, streams, and oceans is heated up by the sun and converted into water vapor. This vapor rises into the air and may result in the development of clouds, which we're going to talk about after this lesson. Many factors can affect evaporation. Think to yourself, what do you think really affects evaporation? Well, we know that when you heat water, makes water evaporate more quickly because water molecules move faster when they're warm. When I think about in the summer, when you see a large puddle and it gets really warm out, that puddle doesn't last very long. So if you've ever heard the phrase, it's not the heat, it's the humidity, I'm sure some of you have heard that. I remember growing up and my mom always would say, oh, it's so humid outside. Well, people say this because humidity, which is the amount of water vapor in the air, can make hot temperatures even more unbearable than they are, which us living here in North Carolina, we fully understand what humid days feel like. Humidity is actually a broad term, and it can describe different types of humidity in different ways. Humidity is an important thing to understand because it affects both weather and climate, as well as global climate change. Humidity also affects indoor environments. So understanding that it can help you determine what's the best place to store your books, clothing, and other important items in your house. I remember at one time I had some candles and I stored them in a container in my garage. Well, guess what? They were no longer usable. The definition of humidity is the measure of the amount of water in the air, which also affects evaporation rates. Water is added to the air by the process of evaporation. For evaporation to occur, the humidity of the atmosphere must be less than the evaporation surface. So a lot of times we hear about humidity, but what we're really hearing about is relative humidity. Relative humidity is the amount of water in the air compared to the amount of water the air could possibly hold. So if you have a measuring cup and your measuring cup can hold 1 cup of water, if we had that measuring cup filled halfway, if it was at a half a cup, then its relative humidity would be 50%. So humidity values are usually given as relative humidity. If the air is holding half the amount of water it can hold, its relative humidity is 50%. If the air is holding all the water that it can hold, so if that example of the cup, if it holds 1 cup of water and it was filled to 1 cup, then its relative humidity would be 100%. If the air is holding no water vapor, then the relative humidity would be 0%. If it's holding 1/4 of the water, it would be 25%. So this chart here shows what happens as the temperature goes up and the amount of water vapor. So think to yourself, what do you see that this line's doing? Is it going up? Is it going down? Is it staying still? Well, if you look at it, starts at negative 20 degrees Celsius and it moves up to negative 40 degrees Celsius. But as the temperature is climbing, also the water vapor is climbing. So what that is telling us is that as temperatures increase, water vapor can also increase. So if the air is saturated, it's holding all the water that it can hold. Warm air expands and can hold more water vapor than cold air. So it takes more water to saturate the air. So if I say something saturated, if I like to think of like a sponge, and if I take a sponge and I soak up all the water that that sponge could possibly hold, and it can't hold any more without then the water dripping out of it, I would say that this sponge is saturated. If the air is saturated, its relative humidity is 100%, which means the air cannot hold any more water vapor. So if you're ever looking on Weather Channel or you're looking at Brad Panovich's site and you see that he has that the relative humidity is 100%, that means the air is full. It cannot hold any more water. So if the temperature drops, precipitation will occur. If the temperature goes up, because warm air can hold more water vapor than cold air, then the relative humidity will go down. At 100% relative humidity, there's no evaporation. So things that affect relative humidity. The two factors are, one, the amount of water. If you increase the amount of water in the air by adding it due to evaporation, relative humidity will go up. Two, temperature. Since warm air can hold more water than cold air, if you lower the temperature, the relative humidity will go up, even if you don't add any more water. So if you look at this example, here's a visual to help you understand. So if we have that same drop of water, so at 10 degrees Celsius, that drop of water is at 100% relative humidity. So remember, 100% means the air is saturated, it cannot hold any more water. Now it's 10 degrees Celsius warmer outside. So now that same drop of water at 20 degrees Celsius is only at 52% relative humidity. Now it's even 10 degrees Celsius warmer. So now that same drop of water is at 28% relative humidity. So as the temperature went up, the amount of water vapor in the air stayed the same, but because warmer air can hold more water vapor than colder air, the relative humidity went down. So how do we measure humidity? How do we know if there's what amount of water pressure in the air? So we can use a psychrometer. A psychrometer is made with two thermometers. One's covered with a wet cloth. When air moves over the wet cloth, evaporation occurs, lowers the temperature on the thermometer. If you compare the temperatures on the two thermometers, you can get the relative humidity. So condensation. We're all familiar with condensation. If you were in class right now, there was probably someone that had a water bottle sitting on the table and there's a ring of water around the table. Was it that the water bottle was leaking? Probably not. It's probably due to condensation. Condensation is the process by which gas, such as water vapor, becomes a liquid. Condensation will occur when the air is saturated or has a relative humidity of 100%, which means the air cannot hold any more water vapor, so the water condenses out of the air. This commonly happens when moist air is cooled or comes in contact with a cool surface. So like the example of that water bottle, condensing on your table shows you that the water cooled the air molecules around it, brought it down to being saturated. It was the relative humidity couldn't hold any more water vapor, so it condensed, and it condensed on the table. Dew point is the temperature at which condensation will occur. Dew point is the temperature the air must be in order to be saturated. So every time you look at the weather, you're always going to see a temperature for the dew point. So what it's saying is that if the air drops to that dew point, you are going to see either condensation or you're going to see some sort of water vapor on, and sometimes it's in the form of dew on the grass in the morning. So remember, cooling the air makes it unable to hold as much water vapor, so water will condense out at a certain temperature. I hope you understood humidity, relative humidity, saturation, and dew point. Later, we're going to watch a video to help us even understand some more about this topic.